Last on our list in the current module, but natural language processing is a field into which tons of resources and research are being thrown at. Let's look at what it is in more detail. Let's say you're in a restaurant in a foreign country. The menu seems to be entirely in the local language. You pull out your phone, open up an app like Google Translate, scan the menu, and out pops the version translated to your language. This is something I've encountered many times. And that right there is natural language processing at work. So what exactly is natural language processing? NLP, or natural language processing, is a branch of AI that allows computers to understand, analyze, and interpret text and spoken word in the same way human beings can. NLP enables computers to understand natural language as humans do. Whether the language is written or spoken, natural language processing uses artificial intelligence to take real-world input, process it, and make sense of it in a way a computer can understand. So how does it work? NLP has two main phases: data pre-processing and algorithm development. Data pre-processing involves preparing and cleaning text data for machines to be able to analyze it. Pre-processing puts data in workable form and highlights features in the text that an algorithm can work with. Let's look at some of the ways that this is done. First is tokenization. This is when text is broken down into smaller units. Tokenization can separate sentences, words, characters, or subwords. When we split the text into sentences, we call it sentence tokenization. For words, we call it word tokenization. This is the first step in any NLP pipeline. Then, we have stop word removal. This is when common words such as a, the, how, from, etc. are removed from text, so unique words that offer the most information about the text remain in place. Then we have lemmatization and stemming. This is when words are reduced to their root forms to process. And finally, we have part of speech tagging. This is when words are marked based on part of speech they are, such as nouns, verbs, and adjectives. Once the data has been pre-processed, an algorithm is developed to process it. There are many different natural language processing algorithms, but two main types are commonly used. One is a rule-based system. Rule-based systems rely on handcrafted grammatical rules that need to be created by experts in linguistics or knowledge engineers. This was the earliest approach to crafting NLP algorithms, and it's still used today. Then, we have machine learning-based system. Machine learning algorithms use statistical methods. They learn to perform tasks based on training data they are fed and adjust their methods as more data is processed. Using a combination of machine learning, deep learning, and neural networks, natural language processing algorithms hone their own rules through repeated processing and learning. Let's look at a simple example of text classification using machine learning. We have some text in a document, and we also have a tag associated with that text to indicate whether the text is positive, negative, or neutral. We run it through a feature extractor, which gives us the features which are then fed into a machine learning model along with the tags. This part of the system is called training. And then we have the train model. Now, when we have more text data, you can extract the features and then feed it into the already trained model, and that will tell you if the text is positive, negative, or neutral. This part is called the prediction. All of the theory looks very nice, but what are some of the real-world applications of NLP? Analyzing customer feedback. NLP has become an essential business tool for uncovering hidden data insights from social media channels. Sentiment analysis can analyze language used in social media posts, responses, reviews, and more to extract attitudes and emotions in response to products, promotions, and events. Information companies can use in product designs, advertising campaigns, and more. Virtual assistants or chatbots. We've talked about how virtual assistants that live on your phone or TV help you out in your daily lives. While they work with voice mainly, chatbots perform the same function with typed text queries. The top-of-the-line stuff also learn to recognize contextual clues about human requests and use them to provide even better responses or options over time. Spam detection. You may not think of spam detection as an NLP solution, but the best spam detection technologies use NLP's text classification capabilities to scan emails by language that often indicate spam or phishing. These indicators can include overuse of financial terms, characteristic bad grammar, threatening language, inappropriate urgency, misspelled company names, and more. Why is NLP important? Businesses these days use massive quantities of text-heavy, unstructured data and need a way to efficiently process it. This is where NLP is useful. We finally come to the end of this module. I know I've hit you with a lot of information. Let's look at the highlights. First, we had a look at big data. Big data refers to extremely large datasets that cannot be analyzed using traditional methods. Without big data, AI would not exist. Then, we talked about how machine learning is a subset of AI that contains techniques that enable machines to learn with experience. It can be broadly divided into three categories: supervised learning, unsupervised learning, and reinforcement learning. We then moved on to deep learning, which is a subset of machine learning based on neural networks that permit a machine to train itself to perform a task. We saw the importance of forwards and back propagation in deep learning. Finally, we looked at NLP or natural language processing, which is a branch of AI that helps computers to understand and analyze human language. Up next, in the final module of the course, we'll take a look at the effects of AI in the world of business. See you then.